this morning with all of you and to have been preceded by these excellent speakers who've given you a really awesome background into the many problems that we face with high volume hydraulic fracturing. Yesterday I was mentioning to someone that it's a misnomer. We shouldn't call it that. We should call it massively high hydraulic fracturing, horizontal hydraulic fracturing. And that's one of the problems that I just want to mention to you today. Probably the biggest problem is the size of this undertaking. You know, there are so many factors. For one, there's the use or overuse of clean drinking water, which can never be returned back to, can never be purified, go through treatment facility centers and returned back into the drinking water supply, not only because of the radiation in this used water, but because of some of the chemicals. For example, the brine that comes back out with flowback often contains bromide. And in treatment centers, dirty water is treated with chlorine. And the chemical reaction that occurs between bromide and chlorine results in trihalomethanes, which are potent carcinogens. And you would not want trihalomethanes pumped into your drinking water. So basically, the water that is pumped into the process of hydrofracking is what they call consumed. It means it's used and then it is wastewater, and it has to be disposed of. And the enormity of numbers of gallons of wastewater is astonishing, and there are no real solid, satisfactory plans in place right now for how this wastewater can be disposed of. And you may not be aware of this. You think that New York so far is protected from all the fracking stuff that's going on in 17 other states. But let me let you in on a little secret. There is a certain county in southern New York, in the southern tier, that is getting truckloads of wastewater from Pennsylvania hydrofracking operations. And they are also, their municipal group has decided to sell clean drinking water from the 3 rivers that converge in their town. They think that they have adequate water and they can sell it. And when we talk about adequate water, we are talking about water resources for drinking that exist today in an environment when we have an enlarging population for 2 reasons. One is more babies being born and more people moving into the country, and also more elderly people are living longer, so more people are becoming consumers. And this is not a time to be overusing our clean water drinking supplies. In addition to that, we already have a degree of global climate change, which is causing vast arid conditions and drought in the West and even in the East. Last summer, 2012, on Long Island, they actually had forest fires in Long Island because of a drought. So when we are faced with a certainty of changing conditions due to global climate change, we really have to work extra hard to preserve our resources. So now I'd like to start, having talked about that, actually, I wanted to drop some other information with you. Just yesterday, an organization came out with the first paper that I've ever seen that addresses the quantitative threats to people from hydrofracking. Up until now, what we have in evidence is based on qualitative data. We can tell you that we are seeing people with rashes. We can tell you that we are seeing people with diabetes. We can tell you that we are seeing a whole list of acute physical ailments that people are. We can tell you about the amount of dust in the area and the number of truckloads and things like that, but we don't really have statistics across the United States. So this report that was just presented yesterday, it was written by Elizabeth Ridlington of the Frontier Group and John Rumpler of Environmental Health and Policy Center. This is the first article that has been written where they painstakingly strived actually to get statistical information, valid statistical information from across the nation, from at least 17 states where active fracking is already going on. And I have to tell you that the numbers are very shocking, but they are an underestimate of what is most likely the truth. They're an underestimate because reporting in the different states varies, and reporting by the gas and oil companies varies. How much water did they use? How much chemicals did they use? So they had to go with at least what information was available to them. And just to give you a few little statistics, they found that between 2005 and 2012, 250 billion gallons of clean, pure drinking water was totally consumed by the fracking process and turned into wastewater. On the other hand, just in the year 2012, 280 billion gallons of wastewater were produced. So your first question is, how is that possible? How can we have 250 gallons of clean water going in over 7 years and 280 gallons, in fact, 1 billion gallons coming out in 1 year? And the reasons are, first of all, underreporting of usage quantity, as I already mentioned. And secondly, that underground sources of water also contribute to the produced waters that come back after the fracking. The enormity, the vast